Assalamu alaikum. We know an orderly arrangement of spectral lines or waves based on their wavelength or frequency is referred as spectrum. In this video, we'll discuss about the electromagnetic spectrum. What is electromagnetic spectrum? Let me write this on board. Electromagnetic spectrum is nothing but an orderly arrangement of electromagnetic waves based on their wavelength or frequency. An orderly arrangement of waves. Which kind of wave? Electromagnetic waves. Here EMW stands for electromagnetic waves. According to their wavelength or frequency. Based on these two, we arrange electromagnetic waves are arranged in a electromagnetic spectrum. Now, before going ahead, let me tell you how to remember the arrangement of electromagnetic waves in a electromagnetic spectrum. Okay, for that we start with the letter V. Here V stands for visible light. Okay, it is a part of electromagnetic spectrum. Now, in our previous video, we have studied about the solar spectrum. Now we know when a ray of sunlight is when made to fall on a glass prism, it gets dispersed into its constituent color. So it shows a VIBGR. Is that? It shows the 7 colors, the presence of 7 colors in it. What are they? VIBGR. Right? No, these are the 7 colors present in solar spectrum. Here V stands for violet, I stands for indigo, B stands for blue, J stands for green, Y stands for yellow, O stands for orange, and R stands for red. So, you know, to remember this to get the proper arrangement of electromagnetic waves in electromagnetic spectrum. Okay. Now, on the right side of visible light, I mentioned UV. It stands for ultraviolet. Okay, on the left side, what is written? See, it is violet now. After violet, the thing which is relevant to violet is ultraviolet. It is written beside a visible region. And now before the visible region, we write infrared, IR. So here, the beginning is the red. So beyond that, infrared is present. That's why here infrared. And after violet, what is present? Ultraviolet. That's why we get this order. Then in the alphabetical order, in English alphabets, the letter which comes after V is nothing but X. Remember it in this way. Write X, which stands for X-ray. And then last one in this is nothing but gamma. Now this is the symbol of gamma. What is this? This symbol is named as gamma. Now this letter is named as gamma. The gamma ray stands for gamma ray. Now, how many waves we have included here? 1, 2, 3, 4, 5. Only two waves are left here that I am going to mention now. First one here is nothing but radio waves. Radio waves is R. Okay, then afterward, what comes next to this one is nothing but microwaves, mu. This symbol is named as mu. What is this? It stands for mu. This data as mu. Okay, mu is usually used to represent micro. It is used to represent a micro. Okay, micro is 10 power minus 6. So this is the arrangement of electromagnetic waves in electromagnetic spectrum. Now I am going to discuss about these waves one by one. First I'll start with radio waves. First one, radio waves. In each case, first I will start with source. What is the source of radio waves? When charges accelerate in a conductor, it gives out radio waves. Accelerating charges in a conductor gives us radio waves. Remember this. Then we discuss about it's a frequency range. Very important thing. Frequency of radio waves. Frequency range. Frequency range. What is the frequency range of radio waves? See, the frequency range lies between few hertz and 10 power 9 hertz. This is the frequency range of radio waves. Remember this. Now, third thing, now I'll discuss about the properties of radio waves. What are the different properties does it possess? Properties. Radio waves show properties such as reflection. It shows a reflection. It shows diffraction property, and it also shows refraction property. What refraction? Refraction. It also shows refraction. What is this reflection? Now suppose I have a surface here. Some wave or ray, it falls on it and gets it bounces back. This bouncing back of a ray or wave is referred as reflection. Okay, so bouncing back of a ray or light or a wave is referred as reflection. Remember this. What is this diffraction? Diffraction is the property of bending of a ray or wave from the edge of an obstacle. Okay, obstacle means any hindrance in the path of the given wave. And refraction. Refraction is the property of bending of a wave when it travels from one medium to another medium. Now suppose I have two medium. Let's see. This is a air. This is a water. These two media are separated by a line. Okay. Suppose a ray of light enters this medium. The water from air. It travels this way. Once it enters the another medium, what happens? It slightly bent. Instead of traveling in this particular path, it slightly bent. This bending property of a wave or ray is referred as a refraction when it travels from one medium to another medium. Here it is a rarer medium, this is a denser medium. When a light or a ray travels from a rarer medium to denser medium, it bends. It happens due to the reason that here the velocity is high, here it is low. So it travels less, it covers less distance in denser medium because its speed is low. Understand? So these are some of the properties of radio waves. Now the most important thing is the application. No? You study all these things only because they have important applications. Applications means uses. Okay, uses. What are the applications of radio waves? A radio wave is used in TV, radio, and mobile communication. Mobile communication. Communication. Okay. In these three things we use the radio waves. And mobile communication actually to transmit voice message from one point to another point, ultra high frequency band is used. Okay. That's all about the radio waves. Now we'll go ahead. We'll discuss about microwaves. Microwaves. Second one, microwaves. In short form, I usually write it this way: microwaves. Okay. Now here also start with the source of microwaves. I'll start with the source. There are certain special vacuum tubes are available used for the production of microwaves. Okay, like we have klystron, then magnetron, the gun diodes. These are some of the devices which give out a microwave. Okay, here magnetron. I have a magnetron with me. Let me show it to you. The device that I am holding in my hand is nothing but magnetron. Okay. Now it is removed from an old microwave oven. It is a source of microwave in a microwave oven. Okay. So some of the sources of microwave. Now, what is the frequency range of a microwave? Frequency range. Here, the frequency of microwave lies between 10 power 9 Hertz and 10 power 11 Hertz. This is the frequency range. Here up to 10 power 9. Here it starts with the 10 power 9 Hertz and goes up to 10 power 11 Hertz. This is the frequency range of microwave. Understand? Third properties. Now, what are the different properties it shows? It show reflection. First, property is reflection. Okay, and it also exhibits polarization. One problem is called as polarization. Apart from this, it shows refraction as well. So these are some of the properties of microwave. Now, the most important thing, application. Applications or uses of microwave. What are the applications of microwave? Let's find out. Now, we know very well, microwave is used at home in a microwave oven. Microwave oven. It is used in a microwave oven. The second thing, it is used in a radar system. It is used in radar system. In 11th physics, we have studied about radar in detail. What is this radar system? Now, radar in Radar system, microwave is used to navigate the position of an aircraft, and also it is used by traffic police to find the speed of an approaching vehicle. Clear? So these are some of the uses of a microwave wave. Clear? We'll move ahead now. We go to the next wave in the series. What is that? This infrared. Infrared waves or IR rays in a simple form. IR stands for infrared. So what does it do and how it is produced? First source. Any hot object, any hot body is a source of infrared radiation. A hot object. Any warm body, or you can say warm body. Is an example of is a source of infrared rays. Even our body, or if you take any animal, the bodies of animal is warm, so it is constantly giving out infrared radiation. This property is used by military to find the movement of any person or animal in the night time. In a similar way, in forest, the movement of animals can be easily captured with the help of infrared cameras. Okay. Now, frequency range. Frequency range. The frequency range of infrared rays lies between 10 power 11 hertz and 4 into 10 power 14 hertz. Frequency range is this: 10 power 11 hertz to 4 into 10 power 14 hertz. Okay, this is the frequency range of infrared rays. Now, properties. What are the different properties does it possess? Let's find out. Properties of infrared rays. Infrared rays have an important property of heating the object. When it is made to fall on something, it heats up that object. Heating effect. It have got a heating effect. Okay, it heats up the object when it is made to fall on it. And that's how it is used in medicine. How it is used in medicine, that we'll see in the next title. There's applications. Applications. What are the different uses of infrared rays? Infrared ray is used in remote control, all kind of remote control, whether it is TV remote or AC remote, whatever you can go for, makes use of infrared LED. Here I have a remote, TV remote with me. I can see this device, which is that you find at the top of this remote control, is nothing but infrared LED. Whenever some button is pressed, it emits out infrared radiation. Infrared radiation is invisible. All this radiation, whatever we have discussed now, are invisible to our eye. We cannot see them. But IR ray can be viewed through a mobile camera. Okay. Usually, mobile cameras are not provided with infrared filter, so they can be viewed. Now I'll press any switch on this, any button. I hope I can able to see the infrared rays coming out of this. You can see the flash. I'm pressing it. Then press, you can see the flash. This is how infrared ray is used in remote control. Right here. It is used in remote control. And also, it is used in camera, night vision cameras. Night vision camera. What is it actually? Vision cameras. I told you everything. Human body emits out the infrared radiation continuously. So, with the help of a night vision camera, it can be detected. Okay. Next, in a security system, it is used many other. And infrared radiation is not absorbed by fog. So, it is used in aerial photography. So, these are some of the applications of infrared ray. And apart from this, it finds its important application in physiotherapy. It is used by physiotherapists. How it is used by physiotherapist? In physiotherapy, suppose a person has got a sprain or some sort of swelling. In such case, they use the infrared lamp, which emits out infrared radiation continuously. That infrared radiation is meant to fall on that particular part of the body. So it is helpful to treat this kind of sprains in the body. Yeah, there's some of the applications of infrared rays. We'll move ahead. We'll go to the fourth part of this electromagnetic spectrum. This third one. The fourth part is nothing but visible region. Visible region. Okay. This is the visible region among these waves in the electromagnetic spectrum. And here, what is the source? We have a lot of information about this region of electromagnetic spectrum. Now, at home, if it is dark in the night time, we use bulbs. If it is incandescent or tube light or LED, all these are sources of visible light. Visible region or visible light. Okay, what is the source? Incandescent bulb. What is this incandescent bulb? Incandescent bulb is nothing but filament bulb. The source of visible light. And what is this incandescent process means? It is a process of giving out light by heating an object. If you heat an object, it emits out light. This phenomena or process is referred as incandescence. Okay. In a filament bulb, it consists of a tungsten filament. We pass electric current through it. Due to heating effect of electric current, the tungsten filament becomes red hot and starts emitting out light due to incandescence. Understand? And apart from this, sun is a source of visible light. So currently speaking, sun is the source of all kind of electromagnetic waves. Clear? Then arc lamp. I told you sun is some of the sources of visible light. What is arc lamp? In the arc lamp, you might have observed arc welding. They bring one electrode near the another electrode. When it is done so, a spark is produced. That spark appears something like this. It has got two electrodes, which are usually made of some metal, or some cases it is made of carbon as well. If it is made of carbon, then such a lamp is referred as carbon arc lamp. Now, one end is connected to positive potential Another is connected to negative potential, which is of a high value. In such case, due to high potential, high voltage, the air in the surrounding becomes ionized. When they are brought very close to each other, a spark is produced between these two electrodes. Now this is called as arc lamp. Clear? Now properties. What are the different property does it possess? It have quite large number of properties. Like it shows the reflection, bouncing back of light, reflection. It shows the refraction, bending of wave when it travel from one medium to another medium, refraction. Then it shows the diffraction. Diffraction is bending of a wave or ray from the edge of an obstacle. Then polarization. About this we will study in detail. Polarization. Whereas the phenomena of stopping or allowing only one kind of vibration is referred as the polarization. Okay, go ahead. Apart from this, it also show photoelectric effect. Photoelectric effect. Even UV light shows a photoelectric effect that we will discuss later. Now, the properties. Now, applications. What are the applications of visible light? The first thing is, without light we cannot see anything. Now, it is quite known to us. Suppose if I turn off the lamps in this room, you can able to see nothing. So, first it causes vision. Second, it is used to study molecular structure. Study molecular structure. Molecular structure. Fine. These are some of the applications of visible light. Now I'll go to the fifth part of electromagnetic spectrum. What is that? Is nothing but UV region, or UV rays, or UV waves, whatever you can call it. UV stands for ultraviolet. Stands for ultraviolet. Ultraviolet region. Clear? UV rays, ultraviolet rays. What is first? See, we'll discuss the sources of UV rays. Sun is the biggest source of UV rays. It emits a large amount of UV rays. Now, apart from this, arc lamp, then dark light. There is one thing called as dark light. UV rays also referred as dark light. So it is given out by dark lamp. What is the another name of UV ray? UV ray is also referred as dark light because it is invisible. So it is given out by dark lamps. Now I'll show you. I have got one with me that I'll show you. Next are properties. It shows reflection property. It reflects. Now, apart from that, it also shows photoelectric effect. What is this photoelectric effect? Photoelectric effect is the phenomena of removal of electron from the metal surface when some radiation is made to fall on it. Whenever some radiation or wave falls on a metal surface, it gives out electrons. We call this kind of effect as photoelectric effect. Okay, now applications. Okay, one thing I forgot to mention here is the frequency range. Frequency range. What is the frequency range of visible light? The frequency range is between 4 into 10 power 14 hertz and 8 into 10 power 14 hertz. This is the frequency range. I think it is better to write it here for better visibility. Frequency range. What is the frequency range? Between 4 into 10 power 14 hertz and 8 into 10 power 14 hertz. This is the frequency range of visible light. Okay. Now here the frequency range. Frequency range is between 8 power 10 power 14 hertz and 10 power 17 hertz. This is the frequency range of ultraviolet rays. Right? Now we will discuss some of the applications of UV rays. Applications. What are they? See, UV rays has got the property of killing germs, so it is used in sterilization. Sterilization of surgical instruments. Apart from this, it is also used in the purification of water purification. Like in packaged drinking water, you might have came across the word UV treated. Now, water is treated with the UV rays to kill the germs present in them. Water purification. Then afterward, it is used in forensic lab. It is used in forensics. Now it is used in a forensic lab to study the fingerprints of criminals or a fingerprint on any material. Now apart from this, UV lamps are used in bank to check whether a given currency is original or not. Okay, and also this can be used to study the originality or genuineness of a given document. Like here I have a lamp. This is called as a black lamp. I turn on this. It emits out UV rays. Okay. Now when it is made to fall on a currency bill, here I have a currency bill. You can see the portion in which it fall glows with the green light. It shows the fluorescence. Due to this, one can easily find out when UV rays are made to fall on some document or a currency. If certain portion glow, means that the currency or document is said to be a genuine one. Okay. So I can include one more property here known as fluorescence. Just now you observed it. Also shows the fluorescence. Fluorescence is another property. What is this fluorescence? When radiation such as UV light falls on certain substance, that substance glow green or it emits out a blue light. Such kind of property is referred as fluorescence. In a highway side, you might have observed signboards. When light falls on such a signboard, it starts glowing. Okay, that phenomena is referred as fluorescence. Now we'll discuss the next region of electromagnetic spectrum. There's nothing but X-rays. We'll talk about the X-rays. Now before going ahead, let me provide some additional information about UV rays. As I told you earlier, UV rays are given out by sun in large quantity. UV radiations are harmful to human body. So there is a layer around the earth called as the ozone layer. The work of ozone layer is to absorb UV rays entering the earth's surface. So a large amount of UV radiations are absorbed by ozone layer. Only a small amount reaches us, which is not harmful to that extent. And apart from that, it shows its highest effect on our eyes. That is why if you go and purchase any sunglasses, it comes with certain specifications as UV 100 or UV 400. It is better to go for the purchase of UV 400 sunglasses. Now what does this 400 or 100 represent? Here 400 represents 400 nanometer, the wavelength of UV region or UV rays which it stops. It can able to stop up to 400 nanometer UV rays, and the UV 100 can able to stop only up to 100 nanometer UV radiation. Okay, that's all about it. Now let's go ahead. Let me notice what are the sources of X-rays. In a lower class, you might have studied about X-rays. X-rays are generated by a special discharge tube called as Coolidge tube. Coolidge tube. Oh, in the lab, it is produced with the help of Coolidge tube. And apart from that, when fast electrons are made to collide a target having a high atomic number, then X-rays are emitted out. Okay. Fast electron hit a target with the highest atomic number. It gives out X-rays. Okay, these are the sources of X-ray. And the next frequency range. Frequency range of X-rays. Here, the frequency of X-ray lies between 10 power 17 hertz and 10 power 19 hertz. This is the frequency range of X-rays. Now, we'll discuss some of the properties of X-rays. X-rays shows the property of reflection. It can reflect. Show the property of reflection. It shows the property of diffraction. Diffraction property of X-rays plays a very important role in the study of the structure of crystal. Okay, so there are important properties of X-rays. Apart from this, it also shows one more property called as ionization. Ionization. Then even fluorescence is the property of fluorescence. Phosphorescence are some of the properties of X-rays. What is this ionization? Ionization is the process of conversion of a molecule or atom into ions. Okay, it is the phenomenon of conversion of atom into ion. Clear? So whenever X-ray pass through a gas, the molecules or atoms present in that gas turns into ions. So it is referred as ionization. So highly ionizing radiation, harmful to human body. Not only X-rays, any kind of ionizing radiation is harmful to human being. Now, we'll discuss the applications. It has got quite a large list in this section. It is used in the diagnosis of tuberculosis. Diagnosis of TB. Then it is used to diagnose or detect any fracture. Detect a fracture in the bone. And apart from this, it is also used to find any kind of flaws or defect in iron beams. Now, iron beams are used to support the construction of a building. If they have any kind of a bubble or some crack within them, then it may destroy the building in which it is used. So, to find out such flaws without destroying the material, X-rays can be used. Got it? And with the help of this, one can also detect the presence of a tumor. It is also used to diagnose a tumor. Now, we will go to the last part of electromagnetic spectrum. That's nothing but gamma rays. Gamma rays. This is a symbol of gamma rays. Gamma rays. What are the sources of gamma rays? Sources. All kind of radioactive substance. Now there are certain elements whose nucleus emit out radiation continuously. Now we call such substance as a radioactive material or radioactive substance. So all sort of a radioactive substance emit out gamma rays. Most of them. Then electronic transition or a transition within the nucleus also give out the gamma radiation. And apart from this, decay of radioactive substance. This is what I said earlier. Actually, radioactive substance. When a radioactive substance decay or disintegrate, they emit out the gamma rays. What are the properties do they possess? Now, before that, frequency range. The frequency range. The frequency range of gamma rays lies between. It has got a frequency of the order of 10 power 18 Hz and above. This is the frequency range of gamma radiation. Now, properties. It has got highly penetrating power. The penetrating power of gamma rays is more than that of X-rays and UV rays. Now, both the X-rays and UV rays also show a penetrating property. They can pass through the many substances very easily. But here the penetrating power of gamma is very high compared to X-rays and UV radiation. Penetrating power. Penetrating power. Is very high. Clear? And it can able to ionize the gas through which it passes. Next is ionization. It shows the property of ionization. Okay. Now the last one is the applications of gamma rays. I told you gamma rays are harmful to human being. It causes cancer. When someone come across gamma rays for a long time, when someone is exposed to gamma rays for a long time, he has the possibility of getting cancer. But in the similar way, cancer is treated using gamma rays. Cancer treatment, it is used in cancer treatment. No? And apart from this, nuclear structure can be studied with the help of this. Study nuclear structure. And in a similar way, I forgot to mention, X-rays are used to study the structure of crystal. Study crystal structure. Okay, in a similar way, UV rays can also be used to study the atomic structure. Study atomic structure. And we use a visible light to study molecular structure. So these are some of the properties, applications of electromagnetic waves that we find in electromagnetic spectrum. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.